Is there a memory you have that's so painful, you wish you could just delete it? A moment of heartbreak, a traumatic event, a failure that still stings every time you think about it. Or maybe it's the opposite. A moment of pure joy you wish you could feel with the same intensity as the first time. For the longest time, the idea of editing our memories was pure science fiction, the stuff of movies like Eternal Sunshine of the Spotless Mind. The power to selectively erase the bad and enhance the good felt like a fantasy. But what if I told you that scientists, right now, are figuring out how to do just that? In labs across the globe, researchers are developing technologies that can dial down the emotional pain of our worst experiences and even implant entirely new, false memories. This is no longer a movie plot. This is the cutting-edge science that's turning fiction into a fascinating and maybe even frightening reality. The journey to changing a memory starts with a simple question. What even is a memory? If you picture your memories as little movie files, stored neatly in a cabinet in your brain, you're not alone. It's a common way to think about it, but it's also completely wrong. The truth is far more complex and frankly more incredible. Our memories aren't static recordings of the past. They're dynamic, living things constantly being rewritten and rewired. Every single time you recall an event, you aren't just playing back a recording. You are actively reconstructing it. To understand how you can change a memory, you first have to understand how it's made. It all happens at the microscopic level. When you experience something, the smell of rain, the face of a loved one, a specific group of brain cells or neurons fires in a unique pattern. Think of it like a lightning storm in your brain where certain clouds always flash in the same sequence. The more you repeat that experience or recall that memory, the stronger the physical connections between those neurons become. This process is called long-term potentiation. It's the brain's way of saying, pay attention. This is important. These interconnected neurons are what scientists call a memory engram, the physical trace of a memory. For decades, the theory was that memories were encoded in these engrams. But the truly revolutionary discovery was that these engrams aren't set in stone. They're surprisingly malleable. Every time you access a memory, the engram that holds it becomes unstable for a brief period. It's like pulling a freshly fired pot from a kiln while it's still hot. For a moment, you can reshape it before it cools and hardens again. This process is called reconsolidation, and its discovery has opened the door to a world of memory manipulation once thought impossible. Researchers realized that if they could intervene during this reconsolidation window, they could potentially change the memory before it settles back into the brain. They could weaken it, alter its emotional charge, or even hijack it to link to new information. This isn't just theory. It's being put into practice. The implications are staggering. It's offering new hope for treating some of the most debilitating conditions, from anxiety to PTSD, but it also raises profound questions about who we are, if our past is no longer a fixed story, but an editable document. Imagine having a remote control for your most painful memory. You can't delete the event itself, but you could turn down the volume on its emotional venom, leaving only the facts behind. This is one of the most promising frontiers of memory manipulation, and it's being pioneered not with futuristic lasers, but with a common class of drugs. The target is the emotional gut punch that comes with a traumatic recollection. That charge is largely driven by the hormone norepinephrine, also known as adrenaline. It's what makes your heart pound during a stressful event. It helps burn that event into your memory with such terrifying clarity. So, scientists asked a simple question. What if we could block adrenaline while a person is recalling a traumatic memory? Enter beta blockers, like the drug propranolol. These are often prescribed for high blood pressure and performance anxiety because they interfere with norepinephrine. Researchers began clinical trials with patients suffering from post-traumatic stress disorder. The protocol was straightforward. Patients would take a dose of propranolol, and about 90 minutes later, in a safe setting, they would be asked to recall their traumatic memory by writing or reading a script of their experience. The goal was to force the memory into that vulnerable reconsolidation window, but this time, with the emotional accelerator pedal chemically blocked. The brain tries to resave the memory, but the intense fear originally tied to it is muted. The results from these trials have been remarkable. Patients don't forget the trauma, but they report a significant reduction in their emotional and physical response to it. The memory becomes less of a recurring nightmare and more of a distant, manageable event. Studies have shown lasting reductions in PTSD symptoms, though it's important to note that results can be mixed and more research is needed to determine when and for whom this treatment is most effective. This highlights a crucial distinction. It's not about erasing the memory, but changing its emotional weight. The facts remain, but the sting is gone, and it's not just limited to drugs. Techniques like transcranial magnetic stimulation, or TMS, use magnetic fields to stimulate or inhibit specific brain regions involved in memory and emotion. Aiming for a similar effect without pharmaceuticals, the goal is the same: to give people control over their past so it no longer controls their present. If turning down the volume on bad memories sounds like sci-fi, the next chapter takes a monumental leap into territory that is both uninspiring and unsettling. Creating new memories from scratch. This is made possible by a revolutionary technology called Optogenetics. Optogenetics gives scientists an incredible level of control, allowing them to switch specific neurons on and off with light. They do this by inserting a light-sensitive protein from algae into the DNA of targeted neurons in lab animals, usually mice. Once tagged, these neurons can be activated simply by shining a thin beam of blue light on them. This led to a groundbreaking experiment by researchers Steve Ramirez and Sue Liu at MIT. First, they let a mouse explore a specific environment, box A, as it explored. The neurons that fired to create the memory of box A were tagged with those light-sensitive proteins. Next, they moved the mouse to a completely different environment. Box B, while the mouse was in box B, the scientists did two things at once. They delivered a mild foot shock, and they shined a blue light into the mouse's brain. Activating the memory of the safe box A, the mouse was now experiencing the fear of a shock, while having the memory of box A artificially triggered, creating a false association. The real test came the next day. The mouse was placed back into the original box, aware nothing bad had ever actually happened. But as soon as it entered, the mouse froze in fear. It was reacting to a memory of an event that never occurred. The researchers had successfully implanted a false memory. They proved that activating a memory engram is enough to trigger the recall of that memory. This research demonstrates with stunning clarity that memories are active brain states that can be manipulated to change behavior. It confirms that the brain's code is not just readable, but writable. The leap from manipulating memories in mice to helping people is significant, but it's a journey well underway. The work in optogenetics and pharmacology is laying the foundation for new mental health treatments. While we are a very long way from implanting false memories in humans, a prospect facing immense technological and ethical hurdles, the principles are already shaping our approach to conditions like PTSD, anxiety, and even addiction. The main focus for human application isn't about erasing memories, but about changing their emotional association. For someone with PTSD, a traumatic memory isn't just a recollection. It's a trigger that can plunge them back into a state of fear. Emerging therapies aim to sever that toxic link. As we've touched on, transcranial magnetic stimulation is a promising, non-invasive method being adapted for humans. Unlike optogenetics, it doesn't require genetic modification or surgery. By applying magnetic pulses to the prefrontal cortex, RTMs could help strengthen the brain circuits responsible for emotional regulation, making it easier for a person to manage their fear response. When a traumatic memory surfaces, the principles of memory reconsolidation are also being combined with established therapies. For example, a therapist can guide a patient to recall a traumatic memory in a safe environment, which naturally opens the reconsolidation window. Combining this with techniques like those using propranolol could help the brain more effectively rewrite the emotional script associated with the memory. The potential extends beyond trauma. For addiction, you could weaken the positive emotional link to drug-related memories that trigger relapse. For depression, which often involves a bias toward recalling negative memories, these techniques could help make positive memories more accessible and potent. We are witnessing a paradigm shift where the memories that cause our deepest pain are no longer seen as permanent scars, but as dynamic circuits that can potentially be rewired. The idea of editing our memories is undeniably tempting. We wouldn't want to ease the pain of their worst moments. But standing on this precipice, we face profound ethical questions. If we can change our memories, do we risk changing who we are? Our identity is a tapestry woven from our memories. Our triumphs, failures, joys, and sorrows all contribute to our personal narrative. If you erase the pain of a breakup, do you also erase the resilience you learned from it? If you dampen the memory of a failure, do you also diminish the humility it taught you? There's a real concern that in trying to eliminate pain, we might inadvertently erase the very experiences that built our character. Then there's the potential for misuse. What happens if this technology moves beyond the clinic? Imagine a world where memories could be manipulated for social control or to influence legal testimony. The integrity of justice and history relies on the assumption that memory, while fallible, is fundamentally real. If that can be technologically compromised, the societal consequences could be devastating. There's also a more subtle philosophical question. Is a life without painful memories a better life? Suffering teaches empathy, compassion, and strength. If we pathologize every negative memory, do we risk becoming shallower beings, trading wisdom for comfort? The technologies are being developed to alleviate immense suffering, and for those individuals, the benefits could be life-changing. But the line between therapy and enhancement can be blurry. Who decides which memories are unhealthy and which are simply part of a complex human life? These are not questions for scientists alone. They're questions for all of us. So, can you really change your memories? The startling answer is yes. We've journeyed from the realm of science fiction to real-world labs. Our memories are being revealed not as fixed archives, but as dynamic, editable brain circuits. We've seen how drugs might dull the emotional edge of trauma, and how light can be used to implant false memories in animal models, proving that the code of memory is writable. This research opens up incredible therapeutic possibilities, offering hope for healing deep psychological wounds. But it also walks us into an ethical minefield, forcing us to ask what it means for our identity and our society. When the past is no longer a constant, the power to rewrite our minds is perhaps the ultimate power, and wielding it will demand unprecedented wisdom. The question is no longer can we do it, but should we? What are your thoughts on this? Is there a memory you would change? Let us know in the comments below. If you want to keep exploring the mind-bending science that is challenging our understanding of the world, make sure to subscribe and hit that notification bell.